Hi, I am Akhilesh Kumar Srivastava from ABES Engineering College, Ghaziabad. In today's lecture, we are going to discuss a problem which has been asked in the INFI-TQ examination. The problem number is 13. Let's look at the problem statement. So here is the problem statement, which says that we have been given a chessboard and the size of the chessboard is n cross n. There are some queens placed on the chessboard. These queens are m in numbers. You have to find out what are the pairs of the queens which are in the attacking position. So you have to just count the number of the queens which will be in the attacking positions. For this problem, let's take the test case, the sample test case. Let's take this sample test case, which says that we have the size of the chessboard as 3, and there are 2 queens placed on the chessboard. The position of the queens which are placed on the chessboard are 1, 0 and 2, 0. And how many queen pairs will be there in the attacking position? This is what you have to find. So let's take the whiteboard and solve this problem. So here is a whiteboard, and the problem statement has said that we have been given a chessboard of size 3 cross 3. So let's say that this is the 3 cross 3 chessboard. On this, there are 2 queens placed. The coordinates of the placed queens are 1, 0 and 2, 0. So if I mark the indexes for this, so this will be 0, 1, 2. This will be 0, 1, 2 on the column side. 1, 0 and 2, 0 are the places of the queen. If I mark them 1, 0 here and 2, 0 here, so there are 2 queens which are in the attacking position, these 2, and this is the only pair which is possible. So the pair which is possible for the attacking queens will be 1, 2. So there is only one possibility of the queens being in the attacking position. Let's take the another problem, and let's try to solve that with the pen and the paper. It means on the whiteboard. So here, let's see the problem again and the test case of the problem. Here it is saying that we have been given the chessboard size is 3, it means 3 cross 3, and there are 3 queens placed. One queen has been placed at 0, 0, another one at 1, 0, and the third one as at 2, 0. So let's see the position of the queens. Let's take this is the chessboard. 0, 1, 2, 0, 1, 2. So 0, 0 is the place where queen has been placed. 1, 0 is the place where queen has been placed, and 2, 0 is also the place at which the queen has been placed. So you can see that there are 3 queens and they are in the straight line, and they are all in the attacking position. But what will be the queen pairs which will be in the attacking position? So if I say that this is queen number 0, if I say that this is queen number 1, and let's say this is queen number 2. So queen number 0 and queen number 1 is in the attacking position. Queen number 0 and queen number 2 is in the attacking position. It means these 2 and then these 2. And Q1 and Q2 will also be in the attacking position. So these are the only combinations possible for which the queens will be in the attacking position. You can also think this of like we have 3 queens in the same straight line. Then the total number of the possibilities for the queens to be in the attacking position will be 3C2, or the total number of pairs which will be possible for the queens to be in the attacking position will be 3C2. This is because out of the 3 we are selecting any 2. And once we have selected, let's say Q0 and Q2, then I will not consider Q2 and Q0 as a new pair. This will be considered as the old pair only. So we will have to take the combination of the number of the queens, and 3C2 is the way by which I can solve this problem. This will result you in 3. If I solve the earlier problem where two queens were given in the straight line, then in that case, I need two C2 possibilities, or two C2 possibilities will be there for the pairs, and this value will be 1. I hope you must have got the insight of solving this problem, but let me brief you out a bit more in detail about the same. For finding out the total number of the pairs, you will have to consider all the possibilities for the queens to be on the chessboard. For example, I will have to see for all the horizontal queens on the first line, all the queens on the second line, second horizontal line, all the queens on the third horizontal line, and all the queens on the fourth horizontal line if I have a chessboard of size 4x4. Let's say there are some queens placed on the first line. Let's say there are 3 queens placed on the first line. Then the total number of the possibilities for the pairs will be 3C2 only for the first line. Similarly, if I place some of the queens there on the second line also, let's say 2 queens are placed here, then the total possibilities for these queens to be in the attacking position will be 2C2. Similarly, if I have no queens placed on the third line, there will be 0 possibilities of the selection of the queens in the pairs. And if I have some queens placed in the last row also, let's say there are 3 queens placed on the last row, last horizontal row, then there will be again 3C2 combinations possible because of these queens. So we have selected all the possibilities and we will have to sum these. So this is only including the horizontal possibilities or the queens which are lying on the horizontal lines. Then we will have to check for the another possibility also. It means we will have to look for the queens lying on the vertical line. So this is the first vertical line, and then this is the second vertical line. This is the third vertical line. Then this is the fourth vertical line. And on each of the line, we will have to compute the possibilities. For example, on the first vertical line, I have 2 queens. So there will be 2 C2 possibilities of the combination. Similarly, in the second vertical line also, we have 2 queens. So there will be 2 C2 possibilities. On the third vertical line, we have 2 queens. So there will be 2 C2 possibilities. On the fourth vertical line, we have 2 possibilities. So there will be 2 C2 possibilities here also. Now, having included all the possibilities on the horizontal and the vertical line, we will now have to look for the queens lying in the diagonal, because you must be knowing that the queen is the strongest player on the chessboard, which can attack in any other direction. So after selecting the queens on this side, we will have to select the queens on the vertical line. So let's take a vertical line from left to right. And then you will have to check a vertical line below this. And then you will have to check a vertical line below this. Similarly, you will have to see all the vertical lines above this as well. And then you will have to check the vertical line above this as well. So there are 5 vertical lines. If I consider that this is first vertical line, this is second vertical line, this is third vertical line, this is fourth vertical line, and this is the fifth vertical line. Let's encircle these so that we can make the differentiation of this with the other ones. So on the first vertical line, there are no queens. On the second vertical line, there is only 1 queen. So with 1 queen, there cannot be any other queen which can be placed on the attacking position. So there will be 0 possibilities for this case. On the third line or the third vertical line, we have 3 queens. So there will be once again 3 C2 possibilities of the selection of the pairs. On the fourth line, you can see that there is only 1 queen. Only 1 queen is there. So this will not be considered for making the pairs. Similarly, on the fifth line, we have 2 queens. So there will be 2 C2 selections. It means 1 selection or 1 pair can exist for these to be in the attacking position. Having selected all these, you will then have to check for the queens lying on the another diagonal side. It means from right to left. So this is the main diagonal from right to left. This is the diagonal above this. And this is the diagonal above this. This is the diagonal below this. this is the diagonal below this. So if I number these diagonals, let's say this diagonal is 1, this diagonal is 2, this diagonal is 3, this diagonal is 4, and this diagonal is 5, then the total number of the possibilities for the queens to be in the attacking position on the first line will be 0. As you can see that there is only one queen there. On the second line, we have two queens, so there will be two C2 ways of the selection. On the third line, I have only one queen, so there will be 0 ways. On the fourth line, I have only one queen, so there will be 0 ways. On the fifth line, I have only one queen, so there will be 0 ways. So having seen all these possibilities, you will have to sum these possibilities. So just to summarize this, what we have done, we had to select first all horizontal lines, and then we have selected all vertical lines, and then we have selected all the diagonals from left to right, and then finally we have selected all the diagonals from right to left. Once included all these conditions, and if you will sum the possibilities on all the sides, you will get your answer that how many possibilities the pairs will be there for these queens to be in the attacking positions, or how many pairs are possible for the attacking position queens. Now let's go to the code block and try to solve this problem. Now, before solving the actual problem, I will have to just check that whether I am able to find out the possibilities on the row side, possibilities on the column side, and on the diagonal side. So here is a very small code wherein I have considered that I have a board, and the board is of size n, that I will take the input from the user. After this, I will be printing the horizontal possibilities. You must be knowing that the horizontal possibility means after freezing the row number, you have to move the column numbers. So having selected this, I'm just printing the row number and the column number. And then on the vertical line, by freezing the column number, you are varying the row numbers. So by this, I will be just printing the horizontal line coordinates and the vertical line coordinates. Just to run this, let's run this and just see if my code has been written correctly. So this is my screen. I'm just running this code, and let's see that if this code works fine. So it is asking about the board size. So let's say the board size is 4. So if the board size is 4, then the first row will have the coordinates 0, 0, 0, 1, 0, 2, and 0, 3. And the second row will have the coordinate 1, 0, 1, 1, 1, 2, and 1, 3. The third row will have the coordinate 2, 0, 2, 1, 2, 2, and 2, 3. And the third row will have the coordinates 3, 0, 3, 1, 3, 2, and 3, 3. And you can see that all these things have been printed. And then if you have to select the lines vertically, then the coordinate, we should freeze the coordinate of the column, and then you should vary the coordinates of the row. Similarly, if we have done this, 0, 0, 1, 0, 2, 0, and 3, 0. So this is the first column element. And then for the second column element, we have 0, 1, 1, 1, 2, 1, and 3, 1. For the third column, we have 0, 2, 1, 2, 2, 2, and 3, 2. And for the last column, that is the fourth column, we have 0, 3, 1, 3, 2, 3, and 3, 3. I'm just closing this and just going for the diagonal code. So you must be knowing that for printing out the diagonal, we will have to first print the diagonal, print the main diagonal, then we will have to print the diagonal below that, and then we will have to print the diagonal above that. So just see this again. If this is the case, and if I mark the indexes 0, 1, 2, 3 for the row side, and 0, 1, 2, 3 on the column side, I will first have to print the diagonals or the main diagonal which starts from the left and goes to the right. And then after this, I will print this diagonal. And then after this, I will print this diagonal. The number of entries in the main diagonal will be 1, 2, 3, and 4. And the number of entries in the diagonal just below this will be 1, 2, 3. It means one less than the main diagonal. And the number of the entries on the diagonal below this will be 1, 2. It means one less than the above diagonal. There is no benefit of taking this diagonal because this will have only one queen. So the one queen cannot make a pair with the other one. So that's why we are ignoring the last one. And then let's take this diagonal, and then let's take this diagonal. So the order in which I am printing the diagonal is first is this one, second this one, and third this one. And after printing all the diagonal on the lower triangle, we are picking up the diagonal on the upper triangle. So this will be taken and this will be taken next. Fine. So for this, we have written this code. In this, we are just printing the main diagonal and then the diagonal below this. If we have taken the size of this board as 3 cross 3, 4 cross 4, sorry, then the total number of diagonals, including the main diagonal on the lower triangle, will be 3. It means one less than the size of the board. Hence, we have taken the outer loop, which varies from 0 to n minus 2. It means a total of n minus 1 time this loop will be executed. And just a simple condition to print the diagonal. In the diagonal, if I have started with the ij row number and the column number, the next row number and the column number will be I plus 1 and j plus 1. Similarly, the next one will be I plus 2 and j plus 2. So we have taken, or we have implemented both the coordinates before the printing. So this prints the main diagonal and the diagonal below this. Similarly, we have printed the diagonal above this. If we are printing 3 diagonals on the lower triangle, we will have to print only two diagonals above the main diagonal. It means the upper triangle. Having printed this, we will take the diagonal on the other side. Let's see this will be this one. After we have printed this diagonal from left to right, we will have to print the diagonal from right to left. So for printing the diagonal right to left, we are first printing the main diagonal and then the diagonals above this. And after this, I will print the diagonals below this. So the order in which the diagonals have been printed is 1, 2, 3, and then 4 and 5. So for printing the main diagonal from right to left, I will have to take the coordinates of this as 0 and n minus 1. So row number 0 and column number n minus 1. And accordingly, with the code, these are getting reduced. From right to left, we are first printing the main diagonal and the diagonal above that for the upper triangle, and for the lower triangle, the diagonal and all the diagonals below the main diagonal. So let's test it. Let's run this. And we have taken that the size of the board is 4. We have already printed the horizontal and the vertical entries. Let's test it for the left to right diagonal side. So on the right hand side, we can see that we have a board. The main diagonal will start from the coordinate 0, 0. And then this coordinate will be 1, 1, and this coordinate will be 2, 2. This coordinate will be 3, 3. You can see that in the code we have 0, 0, 1, 1, 2, 2, and 3, 3, which is the main diagonal. After this, the diagonal below this will have the coordinate 1, 0. This will have the coordinate 2, 1, and this will have the coordinate 3, 2. So the same has been printed here. For the last, we have 2, 0, 3, 1. We can verify it with here. So this one will have 2, 0 coordinate, and this will have a 3, 1 coordinate. Having printed this, we will now move for this one, which has the coordinates 0, 1, then 1, 2, and then 2, 3. You can verify it here, 0, 1, 1, 2, and 2, 3. Similarly, the diagonal above this will have the coordinates 0, 2, and 1, 3. So 0, 2, and 1, 3. After this, we have the diagonal from right to left. For printing the diagonal right to left, I'm just removing all these entries. Let's see the coordinates of the diagonals from right to left. So this will have the coordinate 0 and 3. This will have the coordinate 1, 2. This will have the coordinate 2, 1. And this will have the coordinate 3, 0. I think that this is visible on the left-hand side, that the diagonal from right to left has the coordinate this one. After this, we'll be printing the coordinate of this diagonal and then this diagonal. So ultimately, you can print all the diagonals and its entries. Now, having printed all these coordinate values for the different diagonals, if you have the diagonal coordinates, then in each part, you can apply the different sum. It means horizontally, you can sum and then compute the sum C2. Similarly, for the next row, similarly for this row, similarly for this row. Similarly, for the vertical possibilities, we will first count the number of the queens and then apply sum C2. And every sum will be included in the final sum. And then vertically, then diagonally, for each of the diagonal possible, we will find the sum, and then we will find the combination of this with 2, and we'll add it to the final. Now let's see the main code. In the main code for computing the for sum C2, let's say, or x C2, this is simply x into x minus 1 by 2. So this is a function which is computing the NCR. It means if given n the value and r, and we have to compute NCR, then here r is representing actually 2. So the value will be x into x minus 1 by 2 if n is x here. And then we have considered that we have a board of size 10 cross 10, or you can take it 100 cross 100. Let's take a big one. I have declared it globally such that all the elements of this board becomes 0. 0 means there is no queen there. In case in the question or in the test case, it is given that there is a queen. So we will be updating that by 1. So here is the main part where I have accepted the number as a board size. And then we have accepted the number of the queens possible. And then we have taken the input of the coordinates where the queens are. And we have set the board position 1 there. It means if I have if I have, let's say, 2 queens, which are placed at 0, 1, and 1, 1 position. So the board position at 0, 0, 0, 1, and 1, 1 will be updated as 1. Earlier it was 0. It was denoting that there is no queen board. So if I put 1 there, it means there will be a queen board. Then the combination and the total combinations. Combination, it means with every vertical line, what we are finding out, or with every horizontal line, how many combinations we are finding. So for the horizontal possibilities, we have initialized the sum as 0, and we have taken the sum of each of the rows. And whatever is the row sum coming, if that sum is greater than 1, then I'm computing the NCR of that sum. It means NC2 of that sum. Whatever is that coming, we are taking that in the combination, and we are printing that combination. And after that, this combination is added in the total combination. The total combination has been initialized as 0. So we will be doing this with every possibility that we have taken, or every possibility that we have seen in the earlier program. So horizontally, vertically, then diagonally, for each of the diagonal from left to right, from each of the diagonal from right to left, we are doing the same thing. And after this, we are printing the total number of the combinations. So let's test this for in the test case which have been given. So it's asking about the board size. Let's say the board size is 3. The number of the queens, let's say there are 2 queen positions. The first queen position is, let's say, 0, 1. And let's say the next queen position is. So in our test cases, whatever values were given, we will put all those values and we will test our program for those test cases. Just have a look at the test cases. The first test case was that we have been given a size of board as 3 and the number of queens are 1 and the queen which is there is at position 0, 1. So it is very obvious that if there is only one queen on the board, there will be no attacking position. So it is not even worth testing. Let's test the another test case, which is saying that we have 3 cross 3 board and there are 2 queens and the 2 queens are placed at 1, 0 and 2, 0 position. So here is the code. So here is the code and we are running this. It is asking about the board size. Let's say the board size is 3 and there are 2 positions. One is 1, 0, another one is 2, 0. So horizontally, we don't find any connection. Vertically, we find the one combination. It is quite obvious that on the vertical line, we are finding out of a pair. And there is nothing on the right diagonal. There is nothing on the right diagonal. And finally, we obtain the total number as 1. In fact, this is printing that or horizontally, we have no combination. For the vertical lines, we are finding one connection. So up to vertical line, there is one connection. And for the left to right diagonal, there is no connection, but up to the left to right diagonal, because the vertical connections have been included, there is only one pair possible. So this is actually giving the running sum. So for the right to left also, there is no combination possible, but the running sum is 1. So final pairs that is possible is 1, and that is our answer. Let's test it for the another test case. So here is the another test case wherein the board size is 3 and there are 3 queens. Those are placed at 0, 0, 1, 0 and 2, 0. The answer should be 3 in this case. Let us run the program and check. The board size is 3. There are 3 positions, queen position possible. One is 0, 0. Another one is 1, 0. Another one is 2, 0. So obviously there will be 3 possibilities. So up horizontally, there is no connection or no possibility. Vertically, there are 3 possibilities because the 3 queens are lying on the same line. So 3 C2 combinations, it means 3 combinations are possible. For left to right diagonal, we have no combination, but up to left to right diagonal, the running sum is 3. For right to left, there is no combination, but the running sum is 3. Similarly, the final will be, or the final number of the pairs which will be possible to be 3 in this case. So I hope you must have understood this question and how to solve this question, because we are including all types of the possibilities here. So we'll meet with the next problem on the next time. Thank you.